Well, I made a mistake on the original website. I didn't notice it till this semester. That's summer of 2015. To solve the Bernoulli equation, y times y prime minus 2y squared equals e to the x. Okay, here's the story. First we divide by y to get it in the right form. Y prime minus p of x times y equals e to the x times some other, well, some function of x times some power of y. That's what makes it a Bernoulli. And we make the substitution z equals 1 minus y equals z equals y to the 1 minus n. Well, n is, in this case, is negative 1, so it's 1 minus negative 1, so z equals y squared. Therefore, dz dx is 2y dy dx, using the chain rule. So dy dx is 1 over 2y times dz dx. And now we know what dy dx is, this, and we know what y squared is, so we'll make our substitutions. Our y prime minus 2y equals e to the x times y to the negative 1 is 1 over 2y dz dx. That's substituting for dy dx, right? That's from here, right? That goes in there. Minus 2y, that didn't substitute for, and e to the x times y to the negative 1, I just called it e to the x over y. But now we multiply both sides by 2y, and when you do that, you got dz dx equals, here was my mistake before, 4y squared, I had 2y squared, look at the other example and you'll see it, equals 2 times e to the x. And now we'll replace y squared with z, which is what we remember we made that substitution, z is y squared, to get dz dx equals negative 4z times 2e to the x. And now we've got a linear differential equation in z and x. So it's linear first order in z. Integrating factor would be, this is our p of x, negative 4, so e to the p of x dx is e to the negative 4 dx, so that's e to the negative 4x. And we can think of our equation as now as the derivative of z times e to the negative 4x equals 2x times e to the negative 4x, because we multiply both sides of this by e to the negative 4x. And simplifying this right-hand side, we get 2e to the negative 3x, and which, when we integrate both sides, of course, we just get this function on the left, and on the right, integrating had to take a break, had another fix I needed to make. What we get when we integrate both sides, of course, we just get z times e to the negative 4x on the left. On the right side, when we integrate this, 2 is just constant, so e to the negative 2/3 e to the negative 3x plus c. That c is important. And then when you multiply both sides by e to the 4x, so we just get z on the left side, we get z equals c times e to the 4x minus 2/3 e to the x. And since z equals y squared, we can write the solution implicitly as y squared equals c e to the 4x minus 2/3 e to the x. I guess you could take square root of both sides and say y equals plus or minus square root of all that. Let's not say we did.